So I'm going to start this one over because I just had a interruption. So this is PAT 2008. And all the answers are at the back here if you want to take a look. Okay, and what unit they're on and what the concept is about. Okay, so whenever you see a question for number 31, for example, that has to do with sparks and taking clothes out of the dryer, that's usually a question about static electricity. Okay, so is it current electricity? No, it's static electricity. So is that a discharge? Okay, the separation, the sparks are letting electrons flow. Okay, that's your electrical discharge. This buildup of neutral atoms and anti-static sheets absorbing neutral charges, those are just distractors. Okay, when you're doing your calculations, you want to list your variables like we always do. So energy is in joules. Our power was 200 watts. Time, and they were nice and told us the seconds and gave us the conversion, so we didn't have to think too hard about what to use. So that's 21,600 seconds. Using our formula, energy is power times time. Right? You put in the power, put in the time, and calculator says this is the answer. Okay, so if you only had up to here, let's say it was like 400, this many joules, okay, that would be 4.32 kilojoules, but it's not. Okay, it's this many, right? It's in a million. Okay, it's a million, so that's a megajoule. Okay, so we have this here, 4.32, and the clue is that it was 4.32 something. Okay, this question has to do with an electromagnet. Okay, so that was where we have the magnets, okay, and the commutator and the armature, okay, and we have the iron core, and you have your electrical source over here, and some wires. Okay, so the more coils of wire you have, the more electricity is going to flow. Okay, so using fewer coils of copper wire, that's not going to increase its strength, make it a stronger motor. Okay, increase the resistance of iron core? No, we don't want more resistance. Decrease the current? Okay, that means have like a lower voltage. Okay, no, more voltage is nice. Okay, that's going to give you a stronger magnet. Okay, so we don't want to decrease the current. Okay, using a larger iron core? Sure. Okay, so you're going to have a bigger piece of iron here. Okay, that's going to make you better able to strengthen your magnet. Okay, so 33 is A. This one has to do with circuits. Okay, so this is talking about a garage having two lights and a generator. Okay, they're wired in parallel. So we look, okay, they're all in parallel, great. Each light can be controlled separately, so they should each have their own switch. And there's a master switch, okay, that can turn them both off at once. So we're definitely going to need a master switch, okay, that is going to allow us to turn both lights off at the same time. Right, so this one would only turn off these lights. Okay, it's not going to turn both of them off at the same time. So not this one, not that one. Okay, then out of these two, it says each light can be controlled separately. So that means they each need their own switch. Okay, this one has them where they both have their own switch. This one would need its own switch for it to work. Okay, so C is the correct answer there. In 35, there's quite a bit of information here, and you can look at the question carefully, but this might be a good example as to when to read the question first. Okay, so you could glance at this and you say, okay, different years, we've got gigawatt hours, so how much energy is being produced, okay, and we have coal, natural gas, hydro, wind, so it's kind of going up for hydro, mostly wind up and down a little, biomass, okay, but we have some totals here. So what's going on? The combined production of energy from renewable and non-renewable resources, so you put them together, is that going down year after year? No way. Okay, we need more energy every year. Okay, so anything that says they go down, no. Okay, they're steadily going up, right? So, okay, wind goes down a bit. Okay, but overall, these other guys are going up, right? So, as we generate electrical energy from renewables going up, does that make us decrease our non-renewables? Are these numbers going down? No. Okay, we still need more fossil fuels. Okay, so in general, you put them both together. Okay, is the total going up year after year after year? Yes, it is. Okay, this one I also did ahead of time. So to get 100,000 joules of heat energy, our hot plate is going to use 800,000 joules of energy. So we tend to lose a lot of energy. Like, things are never 100% efficient. Okay, you always lose a whole bunch of the energy. Okay, so if you're always wondering which one to put on top, okay, it's usually the bigger number on the bottom. Okay, so in this case, 100,000 divided by 800,000 times 100, right? You're calculating the percent. So 0.125 times 100 is 12.5% efficient. Okay, this is a very common question to have, is calculating efficiency, but I find most of you already know how to do that because you always calculate what you get on your tests. Okay, so, and your numerical response, you would have put 12.5 and there would have been a little bubble, 1, 2.5. Okay, so on your Scantron, you want to make sure you fill that out properly. 36 has wet cells. So in a wet cell, okay, as opposed to a dry cell, which is a regular battery, okay, so 1 cell, 2 cells, 3 cells, you need different metals for your electrodes. Okay, so this metal bit, those are electrodes, and they're metals, and they have to be different. Okay, so in this one, nothing's going to happen because both are copper. In this one, nothing's going to happen because both are zinc. This one's zinc and copper, okay. This one's zinc and copper, okay. So we've at least got 2 different electrodes. Now in terms of our electrolyte, okay, that's the juice here. Okay, that's your electricity potion. Okay, plain water doesn't work. Okay, you need something that's going to be able to give up electrons. Okay, and to make them go. Okay, so acid water works the best. Okay, sugar, no. So, not this one, not this one, not this one, this one. Okay, so to make an even higher voltage, you can make a stronger acid. Okay, so if they also often ask which one's a stronger wet cell, the 5% sulfuric acid or the 10% sulfuric acid one. Okay, you would go with the 10%. This one is the circuit diagram. So which one is true? Okay, it's talking about which one is brighter and dimmer. So in a series circuit, so going this way, electrons have to be shared. Okay, through these loops, they don't have to be shared. Okay, so 2 and 3 should be the same brightness, and 1 has to share the electrons with the resistor, so this one should be dimmer. Okay, now let's read the question and see which ones are true. Light bulb 1 is dimmer than light bulb 2, yeah. Which is dimmer than light bulb 3, not necessarily. Okay, 2 and 3 are probably the same brightness. Light bulb 1 is brighter than 2, no. Okay, light bulb 1 is dimmer than 2 and 3, yes. Which both have the same brightness, yeah. Okay, light bulb 1 is brighter than, no. Okay, so C. Okay, this one I did in a different video. Okay, tungsten we don't usually talk about anymore. Okay, that's the thing in these old incandescent light bulbs. So it's this little metal here. Okay, and why do we use it? Because it doesn't allow electrons to flow. Okay, we want them to resist electron flow, and we want them to get hot because they give off light. Okay, protons don't flow. Okay, we want it to resist the flow of electrons. Okay, protons don't flow. And I think I did this one in a different question, in a different video, but we'll see. I'll do it again here anyway. Which component in the circuit shown above is protected by the circuit breaker? Okay, so whatever's on the same loop as the circuit breaker is what's being protected. Okay, so here's the circuit breaker. And if there's an overloaded system, it's going to turn off whichever device is on its loop. Okay, whichever device is on its branch. And it's going to save it from getting that electrical surge and light your house on fire. Okay, so the only one it's connected to here is the furnace motor. Let's see if that's on the list. Yep. Okay, the exhaust fan, no. Okay, there's nothing blocking the flow of electrons there except for this switch. And okay, if you open the switch, it turns that off. Okay, open the switch, turns off the light. But that's not what the question's talking about. Okay, the question's talking about the circuit breaker. Okay, and that's it for this test.